Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Symmetria by Costa. Excuse me. Oh, just got a frog in my throat there. And here are the rules. Rules for solving. Normal Sudoku rules apply. Place the digits 1 through 9 once each in every row, column, and 3x3 box. Renban rules apply. Digits on a pink line form a set of consecutive, non-repeated digits in any order. For example, on or that is. He uses that is instead of e.g., which is for exempli grati, which is, for example, 37465 is a valid length 5 line. So, but this is 6. So we'll use this. We can say then that on this line, you could have something like, let's just use 2 then. 2, 3, 4, 5, 7, and 6. That forms a valid renban because the digits 2 through 7 are consecutive and there are no repeats on the renban. So that's an example of how renban rule works. Then we also have German whisper rules apply where adjacent digits on a green line must have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 or a 9 to maintain a difference of at least 5 between adjacent digits. And the only adjacent digits in normal Sudoku that can be next to a 3 are 8 and 9. So therefore, those are the only digits that can be next to it on a German whisper line. We also have diagonal rule applies, where digits cannot repeat on both positive, which is this diagonal, and the negative diagonal. So in addition to the normal Sudoku rules, where you can't have repeats in any row, column, or box, you also cannot have repeats along the marked diagonals, which is the negative diagonal here and the positive diagonal here. We also have Kropke dot rules apply, where digits on the black dot, probably supposed to mean digits next to the black dot, are in a 1 to 2 ratio. That is, one digit is double the other, and not all dots are given. So for example, if this was a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them. We also have quadruple rule applies, where digits in a large white circle must appear in the 4 squares that's around that circle. So for example, there's a 1 and 2 in this white circle, so therefore it's saying there must be a 1 and a 2 that are in the 4 surrounding cells. Similarly, there's a 1 or 2 in these 4 surrounding cells around this circle. There has to be a 3 or 4 around these 4 in these 4 surrounding cells around that circle. And there must be a 3 or 4 around these surrounding cells, these 4 surrounding cells around this quadruple circle. And that's how quadruple rule works. And then we have region sum lines rules apply, where each segment on a blue line sums to the same total, and box border separates the segments. So as an example, the box border separates this line into essentially line segments of equal sum. So these this segment must equal the same sum as this segment, which gives you a decent amount of information there. And that's it. Good luck and happy solve. Thank you. I appreciate that. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. So let's learn how to Sudoku. Okay. First things first. there has to be a 1 or 2 in one of these 4 boxes. There also has to be a 1 or 2 in one of these 4 boxes. Therefore, the 1 or 2 in box 1, and this is, we'll call this, this is just typical, this is just a, what do we call it? I'm blanking on the name of it. It's a, God, I'm just blanking on what the word is. It's not a tradition. It's a. Anyways, to be able to communicate very easily in to other Sudoku solvers, or even from setting too. We typically number the boxes in typical Western reading notation, which is from left to right and top to bottom. So therefore, this is box 1, this is box 2, this is box 3, 4, 5, 6, 7, 8, and 9. So that's how we typically number the boxes. I'm blanking on the name for what that means, but anyways, because in box 1, we know the 1 and the 2 both have to be in rows 1 and 2. And in box 3, the 1 and 2 have to be in rows 1 and 2. We know that in the rest of rows 1 and 2, you cannot have a 1 or 2. Because one of the 1s is here, one of the 1s is here. That means there's 2 1s in these rows, which means the other cells cannot contain that 1. Similarly with 2. Therefore, where is the 1 or 2 in box 2? They have to be in these 3 cells. Well, the good thing about knowing about German whisper lines is you know that they'll alternate between low digits and high digits. Because if you take the numbers that are low digits, which are 1 through 4, and you take the lowest of them, which is 1, you add 5 or more to it, that gives you 6 or more, which has to be next to that 1, which is the lowest of the low digits. So if you increase the digits, you'll get increasingly fewer options, right? But you know that next to 1 through 4, you'll always have a 6 through 9. And similarly, you can know if you have a 6 through 9, which is a high digit, you'll always have a 1 through 4 next to it, right? Because if you take the highest digit, which is 9, subtract 5 from it or more, you'll get 4 or less, which has to be next to the 9. And therefore, you know 1 through 4 have to be next to a 6 through 9. Well, we know 2 out of these 3 digits must be 1 or 2. And if this were, say we didn't have a 1 or 2 here, say this was a high. If this was high, that would mean this would have to be a low, which would force that to be high. But then they would have 2 high digits here, and where could the 1 and 2 be? They would have to be in the same cell, which is not allowed. So these must be low digits here. So these are both low. They're next to another digit, which has to be high, which is next to another low. These lows have to be next to high digits. These high digits have to be next to low digits, so these are both low. These low digits are next to high digits, so these are all high. These have to be next to low digits, which are these digits, so these are both low. And this is high, and therefore this is low. Now we have a similar pattern for the quads, and I guess is why it's called Symmetria, where we have a 3 and a 4 in one of these 4 cells because of the quad clue, and we have a 3 or 4 in one of these cells because of the quad clue. Where are the 3 and the 4 then? They have to be in row 7 because we have a 3 or 4 in rows 8 and 9, and another both 3 and 4s in row 8 and 9. Therefore, 3 and 4s have to be along row 7. And 1 and 2s have to be along here too. Which means this cannot be 1 or 2 as a low. It's specifically 3 or 4. and 3 or 4 can be next to only 8 or 9. Well, in addition, it's next to 3 unique digits, right? So, and this is also next to 3 unique digits. The only high digits which can be next to 3 unique digits are 8 and 9 specifically. So this is 8 or 9, and this is 8 or 9. Similarly, for the low digits, what are the low digits that can be next to 3 unique digits? They're only 1 and 2, right? 2 can be next to 7, 8, or 9. 1 can be next to 6 through 9, but 3 and 4 are not allowed. So we have a 1, 2, 1, 2 pair now in row 5, which eliminates 1 and 2 in the rest of the row. Because these two are the same, we know that because the region sum line divides the line into segments of equal sum, and they're only 1 digit long. So therefore, these have to be the same. So this has to be a high, and this has to be a high. Well, of the digits that can be on the high that are in a 1 to 2 ratio, you can only have 6 and 8. So these are 6 and 8, which have to be next to 3 and 4. Therefore, we have a 3, 4, 3, 4 pair. These are both high, and they cannot be, and 5, okay, 5 can never be on a German whisper line. So that's another thing. So therefore, this couldn't be 5. These can't be 5 because 5 can never be next to a black crocky dot, because if you 5 is only double of 2.5, which is not a legitimate normal Sudoku digit. And if you double 5, you get 10, which is not a digit. So therefore, the 5 cannot be on a German whisper line. So this has to be specifically 7 or 9 here. And this is 7 or 9, which forces this to be a 5. This is the same as that one, so this must be a low digit. This is the same as that one because it must be a low digit because it's on the how do you say it? It's on a 1 length or 2 length region sum line, which is divided into one cell segments each. So these are the same, which means these are low, this is low. That means we have 4 lows in column 5, which eliminates, and 3 and 4 both low too. So we have 4 lows in column 5, which eliminates any other cell from being a low. We also cannot have a 5, so this can't be a low. This has to be a high. This can't be a low, and it must be a high. Therefore, this has to be a 1, 2, 1, 2 pair here. So this is 1 and 2. This is 1 or 2. This has to be a 3, 4, 3, 4 pair here, which means this is a 3 or 4. The 3 and the 4 are next to both this digit, so therefore this must be a 9, because the only digit next to that can be next to a 4 on a German whisper line is a 9. So this has to be 9, which makes this an 8. This 8 means this can't be 4, because again, 4 can only be next to a 9 on a German whisper line. Therefore, this is 3, which means this has to be 4, which makes this a 4. Therefore, this is a 3, because these are the same digit, remember. The 4 can only be next to a 9 on German whisper line, so this is a 9. This is 6 or 8. This can't be 9 because of this 9, so this must be a 7, which forces this to be a 9. The remaining digits here, this is 1 or 2, and this is 1 or 2. This has to be 6 or 7, and this is 6 or 7. Okay. The 3 can only be next to 8 or 9 on a German whisper line, and this is a 9, so this can't be 9. This has to be an 8, which makes this an 8. So this is 8 is in a 1 to 2 ratio with 4. This 8 makes this a 6, which makes that a 6. 6 is in a 1 to 2 ratio with 3. 6 can only be next to 1 on a German whisper line. So this is 1, and this is 1. This must be 2 then because of this 1. This must be a 2 also. And it cannot be 6, 8, or 9, so this must be a 7. Okay. What else do we know? Okay, these are 6-length Ren bands, which means there has to be a 4, a 5, and a 6 on these Ren bands? Well, neither of these could be a 6, and this can't be 6. So 6 has to be one of these three cells. We're not sure which. We just know it has to be one of those three. There cannot be a 3 or 4 here. There cannot be a 3 or 4 here. But we know there's a 4 somewhere on this Ren band line, right? Because it's either 1 through 6, 2 through 7, 3 through 8, and 4 through 9, but all of them contain a 4. So 4 has to be one of these two cells, which means 4 cannot be here. So 4 is one of these two, which means 4 cannot be here. So then 4 has to be one of these 4. Well, it can't be here because it sees that 4. It can't be here because it sees that 4. Therefore, one of these two is a 4. Because again, you have 1 through 6, 2 through 7, and 3 through 9. Similarly, okay. Well, I was going to say none of these two could be 4 because of these 4s. Actually, none of these two could be 4 because of these 4s. Sorry, I apologize. I missed that, actually. There could have been a 4 in this cell specifically, because none of these can be 4 because of the 3-4 pair in the quad. But this can't be a 4 because of this 4, and these can't be 4s because of these 4s. Similarly, these can't be 4s because of this 4. This can't be a 4 because of the 4 in the quad. Has to be one of these 4 cells. So this can't be a 4, and this can't be a 4 because of that 4. Therefore, in this Ren band, we need a 4 on this Ren band, and it can't be here, and it can't be here. So therefore, it must be one of these two, which means this can't be 4. 4 cannot be on this diagonal, so none of these could be 4. Again, this can't be 4, but this could be 4, or these could be 4 here. We're not sure which. But where is the 4 in column 4, right? It cannot be this one, because if it's here, this would mean this is a 4, and then this Ren band would not have a 4 possible, because there would be a 4 here and a 4 here, eliminating a 4 as a possibility in any of the Ren band, which is not allowed. So these can't be 4, therefore this must be a 4, which means this can't be 4. These can't be 4 along this Ren band, along this diagonal, because of the 4 here. And neither of these can be 4, so one of these two is a 4, which means this cannot be 4. Well, where's the only possible 4 now on this Ren band? It has to be here. So this is a 4, which means this can't be 4. Also, this can't be 4 because we have a 4 now on the Ren band. That forces this to be a 4 here. Okay, what else do we know? We don't know about 3s. We know there's a 5 and a 6 on the Ren band also. But 5 cannot be here and cannot be here. So 5 has to be one of these two or one of these two. 5 has to be one of these two or that one. 5 has to be one of these two or this one. And 5 has to be one of these two or this one. Okay. We know 6 is one of these 3. What else do we know? This cannot be 1, 2, 3, 4, 8. So this is 5, 6, 7, or 9. And this is 5, 6, 7, or 9. Oh, this has to be a 2 because of this 2. So this is the same. This is a 2, which makes this a 1. This is a low. This is a low. So this is 5, 6, 7, or 9, but it can't be 7 because it sees that 7. So this can't be a 7. It's 5, 6, or 9. Well, whatever digit this is, if it's 5 or 6, it has to be here. Let's see, what else do we know? These digits remaining here are 2, 4, 5, and 8. That's 2, 4, 5, and 8. But this cannot be 2. So this is 4, 5, 8. This can't be 4, 8, so this must be 2 and 5 here. Well, we have a 4, 5 pair. We have a 2, 5 pair in box 6, which eliminates 2 and 5 in the rest of the box. Therefore, this can't be 5 anymore. So we have a 4, 8 pair here. This can't be 4 because of this 4, so this must be 8, which makes this a 4. So this cannot be 4 anymore. Where is the 4 in box 3? It cannot be either of these cells because of the 4s in those columns. Can't be here because of the 4 in the row. It can't be here because of the 4 on the diagonal. So it has to be here. So this is a 4. Where is the 4? Well, we have 8 4s now. We know where the last 4 has to be. It has to be here. So this is a 4. It's also a low. This is a low. Okay. What else do we know? This is 2 and 5. The remaining digits, this can never be a 5. So the remaining digits in box 4 are 1, 3, 5, and 6, but this can't be 5. So this is 1, 3, or 6 here. This is 1, 3, or 5, because 6 has to be one of these two cells. Remaining digits in box 5 are 1, 3, 7, and 9. 7 cannot be either of these, so 7 has to be one of these two. 3 can't be either of these, so 3 must be one of those two. 1 can't be either of these, so 1 has to be one of those two. 9 can't be either of these, so 9 has to be one of those two. Interesting. What else do we know? We know, 5 cannot be here because of the diagonal, so therefore this can't be 5. This has to be 6 or 9. Okay. Therefore, one of these is a 5. The remaining digits in box 8 are 2, 5, 6, 7, 8. Cannot be 2. Could be 5, 6, 7, or 8 are valid here. And this is 2, 5, 6, 7, or 8. But this cannot be, this is the same digit as that. It's 2, 5, 6, 7, 8, but it cannot be 5 because it sees that 5 on the diagonal. So this is 2, 6, 7, 8 here. Okay, so where is the 6 on this red band line? Cannot be here, can't be here. It has to be one of these cells. So one of these is a 6, which means this cannot be 6. This has to be 9, which makes this a 9. Therefore, this can't be 9 because of these two 9s. So this must be a 1, which makes that 7, which makes that 3, which makes that a 9. Therefore, these can't be 9 either. These can't be 6. So this can't be 6 because of this 6. I forgot to delete that anyways. This can't be 7 or 8. So we have a 5, 6, 5, 6 pair in box 8, which eliminates 5 and 6 in the rest of the box. Therefore, this can't be 6. This has to be 7, which forces this to be 6. Neither of these can be 6 then. So we have a 5, 7, 5, 7 pair, which eliminates 5 and 7 in the rest of the column. So this can't be 7. This can't be 5 or 7. So this is 2 or 8, which means this can't be 5. This can't be 7 because one of these is 2 or 8. This can never have a 9. So now we know this has to be specifically 1 through 6, 2 through 7, or 3 through 8. Either way, they have to have a 3. And none of those two could be a 3. So one of these three is a 3. These can no longer be 1. So it's specifically 3 or 5 here. And therefore, this can't be 3, 1, or 6. Okay. This can no longer be 1 because of the 1 in... So one of these two is a 1. These can no longer be 2. So 2 is one of these two. So 1 has to be one of these two here, which means this is... And therefore, this has to be a 1 here. Because these cannot be 1 because of these ones. Oh, this can't be 6 anymore. So, where is the 6 now on this red band? Cannot be here or here. Can't be here. It must be one of these two on this red band, which means 6 cannot be along this diagonal. So 6 has to be either here or here on this red band. What about here, actually? What about this red band? Well, this can't be 6, this can't be 6, and this can't be 6 here. That can't be 6 here. So one of the 6s, again, these can't be 6 because of the 6s here, and this is a 4. This can't be 6, so one of these two has to be a 6, which means this can't be 6. Therefore, this is a 6 here. Now, if this were 1, the problem with this being 1 is it would require a 2 on this run band. But none of these can be 2. These two can't be because the 2 has to be surrounding the quad circle. And so this one can't be a 2 because of this 2. So this can never be 1. Well, where is the 1 in this quad circle then? It has to be here. So this is 1, which means none of these can be 1 here. So one of these is 1. Well, if this is 1, where is the 2 on this red band? Again, it cannot be any of these cells because they're not surrounding the quad with a 2. Can't be here because of this 2. And this one cannot be a 2 because of that 2. So this cannot be 1 either. Therefore, this must be a 1 here. Which means this can't be 1, so this is 6, which makes this a 1. Therefore, the rest of these digits are 2, 3, 4, 5, and 6. Well, this can't be 3. These can't be 3 because they have to surround the quad. Where is a 3 possible here? It has to be here. So this is 3, which means this can't be 3, this can't be 3, and this can't be 3. This can no longer be 3, so this is 5, which makes this a 3. So this can't be 3 here. Where is the 3 possible now in column 3? Can't be here. Can't be any of these because of the 3's in the boxes. It must be here. So this is a 3. This has to be 2, 5, and 6 on this red band to form a 1 through 6 complete set without repeats. So this is 2, 5, or 6. We can remove the outsides. And this is 2, 5, or 6 as a possibility. Okay. What does that mean? Not too much yet. This we don't know. This could have a 2. Okay, so one of these is a 2, which means this can't be 2. Therefore, this has to be a 2 to complete this red band. This can no longer be 2, so this is 8, which makes that a 2. That makes that a 2. This has to be at least 4 through 8, which means it's either 3 through 8 for 6 digits or 4 through 9. So 1 can never be on this ren band, so this can't be 1, which forces this to be the 1 as the only possibility in column 7. Now we have 8 sevens. Sorry, 8 ones. So we know where the last one is. It has to be here. So this is a 1. On this positive diagonal, what are the digits remaining? It has to be 2 and 8. And 2 can only be on around this quad cell. So this is 2 and this is 8. Therefore, this ren band has to be specifically 2 through 7. So this is specifically then 3, 5, or 7. This is 3, 5, or 7. This can't be 3, so this is 5 or 7. Well, we have a 5, 7, 5, 7 pair on this ren band, so therefore this can't be 5 or 7. This has to be a 3. This can't be 6 because of this 6, so this is not a 6. This can't be 5 because of the 5, 7 pair in the row. And this can't be 2 because of this 2 here. So this must be the 2 as the only place where it can be now. And this has a 3 and a 4, but no 2. So this must be 3 through 8 here then. Which means the remaining digits here are 5, 6, 7, and 8. Well, we kind of already knew that. But we have a 5, 7, 5, 7 pair in row 1, which eliminates 5 and 7 in that row. Therefore, we have a 6, 8, 6, 8 pair in box 1, which eliminates 6 and 8 from the rest of the box. This can't be 6 or 8. This can't be 6 or 8. This can't be 5 because of this 5, so therefore this must be a 7, which forces this to be 5. This 7 makes this a 5, which makes that a 7, which makes that a 5. The only digit remaining in row 1 is a 9. The only digit remaining in row 3 is a 7. This can't be a 2, so this must be a 5, which makes that a 2. You can no longer have a 5 on this ren band because we already have one. This can't be 5. The only digit remaining now in column 7 is a 7. So this is 7. We have 3 cannot be here. So this must be a 3. Well, 3 can't be on this ren band anymore, so it has to be 6 and 9. So this has to be a combination of 6 and 9 here. And this is specifically 8. Well, this has to be 8 or 9, and this can't be 8, so this must be 9, which makes that an 8. This 9 means this can't be 9, so this must be a 6, which makes that a 9. This 6 means this can't be a 6 because the diagonals cannot have repeats, so this must be 8, which makes that a 6. Also, we knew that was 8, so... Anyways, this can't be 6 because of that 6, so this is a 5, which makes that a 6. This 5 means this can't be 5, so this must be a 6. The remaining digit here is a 7, the remaining digit here is a 5, and the remaining digit here is a 5. That's how you solve it. Congratulations, you got the solution. More puzzles coming soon. Sounds good. Yeah, so basically... I should be trying to explain more my thought process here. It was just basically that I immediately saw these and they limited things, right? So then I just followed where it went essentially, right? There's enough limitations here that I guess it doesn't really matter how you approach it because it'll basically it should be flow very quickly from one to the next, right? Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.